Okay. Ready? Yeah, come on. No, not one of our students. Bar magnet lies. Okay. So here, what you have is in number 1, you have a bar magnet lying north-south, and then an electron moves from the left to the right.
Bar magnets or like over.
What? What do you want? Okay, KJ, if that's what you want, this is a bar magnet, not a chocolate bar, not a gold bar, but a bar magnet. Right, so which rule do we use here? The right hand grip or the left hand rule?
The right hand grip. Right hand grip. Left hand. Right hand.
Whatever your first instinct is, usually you're better off if you go with the second one in your case, I know. Yeah. So we use the Fleming's left hand rule. So the field is going up. Which way is the current going?
The current is going straight.
Which direction, KJ?
Right.
Now again, remember my advice?
Left.
It's going left because there's an electron heading to the right.
Okay, yeah.
So the current is going left. So which way is the force? Into the page. Into the page. So the answer here is F acts into the page. By using the left hand rule. KJ! We dig that? Groovy man? Yeah? Okay. Okay. Next question. A magnet has flux of 400 milliwebers over a square region of length 2 centimeters. What is the flux density? So, what you have here you've got your region and you've got your uh, 400 milliwebers of flux, and this is 2 centimeters square. So do you remember the formula? The flux density is equal to the flux over the area. So the flux density is 0.400 over 0.02 squared. It's going to be quite large. Maybe even too large, but whatevs. So that's equal 10 to the 6 Tesla. Mm-hmm. Yep. Yes. KJ? What's that? Yeah. Right, now the next one, 3. An electron moves perpendicular to magnetic field of flux density 500 millitesla What is the force if the electron has a speed of 0.01 at the speed of light? So what's happening here, you've got your magnetic field from north to south, and you've got your electron moving through the field, and it's going to experience a force, and the formula is QVB. So it's the charge of an electron, which is 1.6 times 10 to the minus something. We won't worry about the direction or the sign. 10 to the power of minus 19. The velocity is 0.01 the speed of light, which is 3 times 10 to the 8. And the,
Why 0.01?
because I say that in the question, don't I?
Okay, equals
So you get a small force, 2.4 times 10 to the minus 13 newtons.
So I'll add the formula there to answer the question.
Like everything in physics, the question is, do you know which formula and how to apply it? That is the question. Yeah, you see, as I think I was saying this with the KJ before, the difference between maths and physics. In maths, you can usually always start the question, so it's easy to start, and it can be hard to get to the end, to get the answer. But in physics, it's the opposite. Sometimes it's very hard to start the question, but once you start the question and have the right formula, then it's easy to get to the end, like here. So this is quite interesting how different the maths and the physics is. With the maths, once you can start, you should always be able to start, is the question, can you make it to the end? Whereas with physics, the real question is, can you make it to the start?
But I think the problem with the maths in case there is a long procedure.
Yeah, exactly. So the difficulty is getting to the end, whereas the physics is the difficulty is getting to the start. Okay, let's have a look at the next one. 4. Okay. Right, 4. What you've got is two electrons moving in a magnetic field with that speed and the flux and so on. So again, let's say we have the north here and the south here. So the magnetic field goes this way, and the electron, let's say it's going to the right. And you know what, I'm going to try and draw this in 3 dimensions to help.
how many electrons?
2 electrons. Now don't distract me. I'm doing this in beautiful 3D. It's going to be like Avatar. I see, I've already done it wrong. Hang on. Oh yeah. Yeah. This is the north, and this one is the south. So the electron is going to come in this way, into the field. Now, which way is the force? Well, let's use our left-hand rule. So from north to south, so the field is this way, and the current is which way? Is the current to the right or to the left?
To the left.
It is. So the force is downwards. So what will happen when this enters the field? Will it move up, down, left, right? What will happen?
Go down.
It will curve downwards, won't it?
Yeah.
Yeah? So my question is, it's traveling like it's in a circle, and I want to know what's the radius of this circle. So first thing is, do we understand the situation here? So the two electrons enter the field, and they begin to curve on a circular path. And the question is, what is the radius of this circle?
Okay.
So do we at least understand what we're looking for?
Yeah, that is.
Okay, so we have our first formula, F equals QVB. Do we know the Q? We do. It's 2 electrons. This is on your calculator. It comes out as 3.2 times 10 to the minus 19. Do we know the V? What did I say the velocity was? What did I say the velocity was? 0.05 times the speed of light. And do we know the density? It's 0.75. Isn't it? Yeah. Yes. Well, what happened to you?
Came up better than a long time too long.
Oh no, it's extremely late though. The beginning of the end of Sahara, isn't it? Come on. It starts off with being late, then it's being absent, then it's not doing your homework, then it's thinking everything will be okay, and the next thing you know, it's the exams in the morning and you haven't studied anything. Game over. Okay, so let's type this in. That times that times that times that times that. So I get the force is 9.6 times 10 to the minus 12 newtons.
Okay.
But it would be more useful to get the acceleration. So I can say ma equals f. So a equals f over m. So a equals the force divided by the mass of 2 electrons, which is constant number 3 on the calculator. So the acceleration here will be 5.28 times 10 to the 18 meters per second squared. Now, this is moving in a circle, isn't it?
Yeah.
Do you have a formula for the acceleration when something is traveling in a circle? Yes, do you remember what it is? But, no, 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 not that one. I want the other one. V squared over R. Yeah? Do you remember this? For motion in a circle. Yeah?
So we have B and we have A. These together.
If you know to use this.
Yeah.
Yeah? So then the R equals AV squared. So I have the A, so I just multiply this. Oh, did I do something wrong there? A is V squared over R. That's right, isn't it? Is it?
Yes.
Are you sure?
76 positive.
Yes, I think you're right. Oh, sorry, no. My mistake is here. Look. R equals V squared over A. So, I need my V squared divided by A. So what was my V? 0.05 times 10 power 8 squared divided by the acceleration. So you get a very small circle. It's only going to be 4.74 micro meters. So it barely curves down at all. It's a very small radius. Oh no, sorry, I got that the wrong way. It's a very small radius, which means it very quickly curves down. Because if the radius was very big, it means it goes like this, and then a big radius. But if the radius was very small, then it very quickly goes down. So I probably made this a little unrealistic. I think maybe in real life the charge will be bigger and the speed will be slower, but it doesn't matter. The calculation is the same. This here, they like this type of question in the exam. Again, they like the questions in the exam that mixes two sections together. So here you're mixing fields together with mechanics. Did you get the idea? Yeah? Okay, so make sure you have this one written down clearly.
What did you use for the V?
What I was told in the question.
What is the speed of light?
3 times 10 to the 8, I believe.
What's the 3 times 10 to the 3?
You said 3 times 10 to the 3? For the speed of light.
I thought
3 times 10 to the 3 is 3,000 meters per second. You could nearly drive faster than that. What?
3.08 times 10.
To the 8? No. But speed of light? Speed of light is 2.99 times 10 to the 8, I think. Got this? No? No? Got this?
Yeah, we got it.
Not everybody. Will it continue to move in a circle after it leaves the magnetic field?
no,
No. Why not?
because there's no force pushing it up.
Yeah. Mhm. Can I close this?
Yes.
Yep.